Right. Hello. My name is Steve Livesey. I am a Director of Software Development at Travelport.
And hi, I'm Dave Hollander. I'm a Director of Architecture at Travelport, and also the Chair of the Open Travel Architecture Working Group.
And today we're here to talk to you about some innovations and developments in the open source community that the Open Travel Alliance has been doing with a project called Open Travel 2.0 that focuses on modeling of APIs. So the Open Travel Alliance was founded in 1999 as a trade association for travel suppliers, content suppliers, travel agencies, and other supporting technology companies. And its primary goal was to establish a level of interoperability across the travel industry. All different content types: air, car, rail, tour operators. And at first, it was focused purely on XML messaging, which was kind of the mainstream technology of the industry at the time. But since then, has expanded to include OpenAPI using REST and JSON as well. And here you can see this is a number of the main members of the Open Travel Alliance. As you can see, we've got members from all across the travel community. So, why do we need technical and messaging standards or standardized ways of communication across the travel industry? Well, when you look at the travel technology industry, it isn't terribly unique with respect to the volume of messages or the technologies that are used to communicate. There's a lot of mainstream and even non-mainstream technologies that are out there. But what is unique in a lot of ways is the diversity of the information that has to be exchanged. When you think about the differences between how to sell a flight versus a hotel booking or even a golf tee time, there's a lot of different types of information that has to be exchanged, and a lot of different varying levels of detail depending on where you're at in the transaction, in the sales process. And what Open Travel found through its early years while we're developing these standards is that you had a lot of people who had the subject matter expertise to go develop each of these different transactions for all the different content types. But those people were very, very seldom the ones that knew the mechanics of how to write a good, at the time, XML schema. And that the people that were good at designing schemas, conversely, were also not the ones that typically had the subject matter expertise. And over the years, they found that that the process was very labor-intensive and very manual, and it really couldn't scale to the speed with which new travel standards needed to be created.
Yeah, the other thing about the communities, these travel communities have been interoperating, right? Think about airlines. They've been exchanging tickets and exchanging reservation information for decades before the late 1990s when we started Open Travel. So there's a lot of established practice and a lot of established systems. So hotels worked very, very differently than air, worked very, very differently than car rentals. So all of that had to be built into, if we go to the next slide, when we really got started, we had 12 years of trying to build these isolated schemas and isolated models, and the expertise was a real challenge because somebody who really understood hotel reservation systems wasn't the person who really understood how to build the schema. So we took what we've done over those 12 years and we began to say, we need to rationalize it and organize it. And so 2.0 began really as a way of trying to reorganize those schemas to be more consistent. And when we started looking at the practices, what we found is that the common design practices were really established in, about the year 2000 when schema first came out, and didn't account for the new technologies. And so after we started really diving into what the new style guide should look like, that was focused on delivering good objects for developers instead of thinking about the schema in this traditional way, we found that the style guide became really, really complex for somebody to implement. And so we needed to find a new way to do the schema. And that's where this OTM modeling language came from. It actually encourages and focuses the authors to think about the function of the information objects, and then builds the best practices into the tooling and into the compiler that can generate those API artifacts in a very consistent and reliable way. And the output, we really kept looking at the output and saying, if I use this to build my software, am I building good software? And a lot of the design practices that went into the traditional XML best practices ended up being rewritten and changed for that purpose. Next slide. So, one of the first things when you're looking at that is you start to ask, why not use UML? I had a lot of experience with UML in my previous company. UML is great for designing code, which is sort of what we wanted to do, but we needed to design code not from a design spec, but rather from a message exchange viewpoint. And so OTM was really designed for how do I move objects from one location to another? How do I design for that purpose? So we needed to be able to do things like establish common patterns. I wanted to know what a business object was different than just everyday objects. I wanted to have the everyday objects identified in a way that was reusable. So something like an address could be reused everywhere the same way. I don't need a different address just because it's being used in a airline reservation, than in a hotel reservation, than in a golf course reservation. It's still an address. So we made those kinds of distinctions directly into the model. We also made sure that they could represent various levels of the information or various views. If you take a RESTful perspective, those objects are resources, and we can have different views on those resources. And we build that right into the model so that when I want the simple view of an address, I always get the same simple view of an address. The other thing we discovered is versioning was never handled. Sorry about that. Working from home, COVID world. Versioning and configuration is really not dealt with the way most people generate APIs. And we decided to tackle that problem and build versioning directly into the tooling so that version 1.1, version 1.2, version 1.3 have specific meanings. And whether you're looking at an airline or a car or a hotel, when you see a minor version or when you see a major version, you know what the implications are. So as I mentioned before, the idea is to be able to build the artifacts for the software developers. When you do modeling, all too often you see models pasted to the wall that are obsolete on delivery, because as soon as you're done with the model, you start coding, then you don't go back from the coding and update the model. Here we want to make sure that we compile directly the artifacts that are used by the developers, and Steve will talk about that tooling here in a second, so that the model and the artifacts always remain in sync. One of the beauties of doing it this approach is when JSON and OpenAPI, or at that time known as Swagger, became very much a central topic for the travel community, we could just go in and modify the compiler and generate the exact same information payloads in both XML and in JSON. We could have very similar services described in the legacy approach or using Swagger. So the flexibility of keeping the information model separate from the compiler process really gave us the ability to move forward. Steve?
All right, so what is the Open Travel modeling technology? So what is this open source project? It actually began its development at Sabre, who shortly thereafter donated the initial code base to the Open Travel Alliance. And then Open Travel subsequently released it as an open source project in GitHub under the Apache 2.0 license. So what's in the toolbox? So OTM, over the years since the project began, has really evolved into four main areas. We have the OTM DE, which is the OTM development environment, and we're actually on the second generation of this now, which is essentially the editor we used for creating, editing, and editing the models, and then generating the schemas and the other artifacts that you can get from that. So second, we have a repository where the libraries that are created as part of the model can be stored and managed. And so the repository provides not just sharing, but also version control, lifecycle management, access control about who's allowed to edit which libraries of the model.
So not only one repository, but all of that code is in the project, so you can set up your own repositories as well.
Correct. And so the third part is really a series of utilities, and this has kind of grown up organically throughout the project, because we've noticed, as we've seen development teams trying to work with these modeling technologies, there will be certain problems and certain issues they run into, like, hey, I'm trying to build a test and it's hard for me to build a well-formatted and properly populated example message that I can test with. So we've developed a tool that we call the example helper that essentially lets a developer configure and select the configuration of their messages and easily generate example messages, sample messages in either JSON or XML format. We had problems where development teams would say, well, I need to pick up a new version of the model, but I don't know what's changed. And it's hard to tell what's changed. So we developed an ability to compare two different revisions of the model and to report on the differences, where developers would understand kind of what are the development tasks going to be, which parts of their code is that going to hit when they look at the changes. And then finally, we've also had some, where we talked about versioning, we also found that there were some laborious and kind of manual tasks related to upgrading groups of libraries to a new version and making sure the references and everything got upgraded as well. So we've created some automation around that. And then finally, and as Dave was saying before, one of the most critical aspects we feel about any modeling tool is that it is actually included in the software development process. That means that your models are part of your software and therefore will always be relevant and won't be pasted to a wall and be essentially out of date the minute you publish them. So for that reason, I mean, what better way to make it part of a development process than to be able to integrate it directly into your continuous integration processes and pipelines? So over time, we started realizing, and early on, OpenTravel adopted the Open API and the Swagger specification as a mechanism for publishing RESTful APIs and JSON. What we realized is that the two organizations actually have had very similar strategies in that they both produce a specification, but then they use technology and tools built around that specification to foster adoption. And it's been a very effective strategy for both groups. And so it's actually been a kind of a natural evolution that in recent months, the OpenTravel and Open API have formed kind of a joint venture in the form of the Open API Travel Workgroup Initiative. And so where are we going from here? Well, first and foremost, OpenTravel is continuing the development of the shared API specifications for the travel industry. That was kind of the original intent of OpenTravel 2.0. But we're also going to continue exploring this partnership with Open API and looking at how these two sets of tools might have more synergy together. And one of the interesting things that the Open Travel Alliance has realized about, now that we've got this modeling language and this set of tooling, is that there's actually very little in it that's related to travel. It's very applicable to other industries and other applications. And so the partnership with OpenAPI is also a pathway to maybe exposing this to other, to other industries and finding other uses for it.
It's important to note, Steve, that there's nothing in the tooling, there's nothing in the OTM model itself that is travel specific. I could use this for banking, I could use this for my own personal music system. I mean, there's nothing about it that is travel specific. So this technology and this approach can certainly be used anywhere where you need automation to generate APIs. And that's really what it is just a automated way to make consistent and well-designed APIs.
Very true. And so to kind of accelerate our ability to deliver into these new areas and these new usages, the community is starting to get a little more serious about the development and the contributor community. So, like most open source projects, OTM, OTA 2.0 began on a fairly informal basis and, was not terribly structured and was very nimble and able to add new capabilities very fast. Now that we've gotten to the point where we kind of have a critical mass of capabilities that are usable and have been used to develop software in several areas, now we're able to start refining that and bring more people into the community, more ideas for where we could take this. Starting to look at new ways of how Open Travel even publishes their standards. So when you look at how Open Travel has done that in the past, the standards were basically put into a big zip file that you could download off of the website. Okay, now what we're looking at, especially with things like OpenAPI, where we are actually able to publish actual endpoints and that people can touch and feel and use and experiment with, rather than just a static zip file of here are all your schemas and here's all your documentation. So if anybody would like to know more information about either what OTA 2.0 or the Open Travel Alliance are about, or more about the open source project that's developing, please feel free to contact us at the Open Travel website, and we would love to carry on the conversation.
Just an appeal is one of the things that we're looking at is that Steve mentioned the development environment, we call it DEX, OTM DEX, is based on JavaFX, so it's a full-blown application, and its design is for somebody building an entire model of hundreds of interfaces, right? So one single model for all those interfaces requires a much more complex tool than some of the simpler tools. So one of the things we're looking at is how do we do some web-based development and how do we simplify the needs and make it so that it's quick and easy to go in, build a simple API and get it published. So there's lots of opportunities like that.
So at this point, we want to say thank you for listening, and we look forward to hearing from some of you and maybe continuing on the conversation.
And look forward to some Q&A.